Sorry, folks, I forgot to start the recording. We're about 4 minutes in, talking about the algebra of functions. As you can see, we've already done problems 1 through 4. I was just mentioning how in number 4, we're bringing back something that we previously learned. Number 3, squaring a binomial, bringing back something that we previously learned. So it's a matter of college algebra, math in general, is learning something and building on it. You know, it's like building blocks. We keep combining things that we've learned. So some of you may go, okay, according to the algebra, this is the same as f of -8 minus g of -8. F of -8, oh boy, that's going to equal -8 squared minus 3 times -8 plus 1, and then minus, because this is the minus, so this is like the first part. Now when I'm doing the second part, I'm going to do minus the whole second part because I'd have to distribute that through. So G says plug -8 in here, the square root of 8 minus my -8. Wow. Oh, let's see, what am I getting here? 64 plus 24 plus 1. 8 minus -8, 16, 4 minus 4. Oh, okay, I was starting to panic that this might be a really hard one. 88, 89, 85. Hope I did that right. What you think about that so far? Any feedback? Algebra of functions, g of 0 times h of 0. Plug 0 into my g of x function, I get square root of 8 times, plug 0 into this function, my h function. Looks like that's just 2. This is 2 root 2 times 2. I have 4 square root of 2. Yeah. Anybody else? No. Somebody have an answer for number 7? Okay, good. Somebody have an answer for number 7? That played right into what I was talking about earlier. My x can never be -1 in that function. No solution, no soup for you. All right, let's take a look at the evaluate and write the domain. I'm looking for values it can't be. So R of x right here is x squared plus 3. T of x is x plus 4. And again, what can't x be in this problem?
-4.
Yeah, x cannot equal -4. So it's all real numbers except -4. Number 10, let's see, 2 over x times, and t is x plus 4. What can x cannot equal 0. So you got the idea of what's going on here. This is R of x. x squared plus 3 minus t of x, which is x plus 4. I can still put any number in that one. So the domain here is all real numbers. Yeah, this is exciting. But it does have its applications, and that's why we're taking a look at it. Any questions on the first page? Some of you are saying, give me something hard. Give me something really good. And I'm going to do that right now. Here we go. The difference quotient. I'm going to take my time on the difference quotient because I want you all to be able to do this. If you're going on to calculus, you need to learn the difference quotient. So you might as well perfect it now. Okay, so here's a point, x. Okay, up here, since this is my y values, remember we always say this is y or f of x. They're almost interchangeable with everything we do. Almost everything we do, we could say one is the same as the other. Okay, so here's x, which means right here is my f of x. And that gives me this ordered pair, x, f of x. So if I come over here, I'm going to move over a distance, a displacement of h. I'm moving over h. So now I have the point x plus h. And if I go up here, I'd have f of x plus h, whatever that is. And that would be this second point, x plus h, f of x plus h. And this is x and f of x. So I have 2 points. So what's really going on is we have this curve, you know, and at one point it's going up quick and then it slows down. But this line, and we've used this term before, it's the average rate of change. So this is a nice, you know, instead of, hey, things were really good, no, things are slowing down. This guy just keeps chugging right along, okay? And this is the average of how this guy, you know, he's really increasing fast for a while, and then he's not increasing so much. But this secant line right here gives me that, what's called an average rate of change. And that's a huge thing you discuss in calculus, okay? So we're gonna take a look at, oh, there's the term. Average rate of change between P and Q is the slope of the secant line. Hopefully when I said it over here made a little bit more sense. So this guy, we want to look at the slope, that average rate of change. And we know that it's going to be y. Oh boy, here we go. Y minus y over x, right? I'm looking at these ordered pairs. Y minus y over x minus x. So this difference quotient comes from the slope. It does. It comes from the slope. A y value, blah, blah, minus a y value over an x value down here minus the x value. And doing a little bit of algebra on the denominator, x plus h minus x, it gives me just an h in the denominator. So here it is, the difference quotient. And hopefully you're not going, well, whoop-de-doo. But this is important in the world of math. And as I said, you start getting into calculus, and this becomes really important for some things that you're doing. Okay, so I'm going to follow with what I've been doing. I'm going to come down here, find, it's not lost, find the difference quotient for this equation right here. All right, so wherever there's an x, there's an x here. Whatever I put in parentheses, I put in here. So this first thing is x plus h. So I come down here, wherever there's an x, I'm now going to put x plus h. So I'm going to have 5 times x plus h minus 2. Just like we've been doing before, whatever is in here, I'm going to replace over here. My second part is the actual function all over h. This is one of those things where you're practicing them and all of a sudden it's like, dang, I got it. I got it. So once it's set up, once you have the difference quotient, it's a matter of plugging and playing like we just did, and off you go to simplify it. 5x plus 5h minus 2 minus 5x plus 2, because I had to distribute that negative sign. All over h. Some good things are going to happen. See you later, alligator. See you later, alligator. I'm left with 5h over h. Well, heck, that's just 5. Have any of you had calculus? And I do once in a while get a calculus student. And when I do, they say, well, that's the derivative. That's right. That's something called the derivative. Oh boy. I'm going to pause the recording. All right, so I'm going to do the minus. I'm going to do the underline, and I'm going to do h. And I know what's on this right side is just the function. X squared minus 3x plus 8. Okay, the h is the h. This is the function. This is the tricky part. Wherever there's an x, I'm going to put x plus h. So it's going to be x plus h squared minus 3x plus 8 plus 8. Sort of ran out of room there a little bit. Now, something I don't want to say funky, something cool is going to happen. If I multiply this guy out, I get x squared plus 2xh plus h squared minus 3x minus 24 plus 8. Hopefully you got all of that, because that's kind of like the hardest part of the problem once you have this set up. And again, it's a matter of putting x plus h in right there and x plus h in right there. Now I have minus x squared plus 3x minus 8 all over h. Now, why did I write it like that? Because I want to point something out. Check out what happens. Oh, here's an x squared and there's an x squared. Here's a minus 3x. Here's a plus 3x. Here's an 8. Here's a minus 8. Huh. Everything in that second function cancels out. No kidding. So that's the first thing of note, right? That's the first thing. What am I left with? 2xh plus h squared minus 24. What the heck am I doing? That's not a 3. You dummy, that's an 8, an h. This is 3x. Where am I at? Okay, x squared plus 2xh plus h squared minus 3x minus 3h. I apologize. That one right there was a minus 3h. I knew I did it wrong, and I'm going to tell you why in a second. All over h. So I put in the x plus h in the h squared one. I put the x plus h in where the 3 was. Then I had the plus 8. This guy gives me x squared plus 2xh plus h squared. If I distribute, I get 3x minus 3h plus 8 over here minus x squared plus 3x minus 8. So my first thing was everything in that second function ends up getting canceled out. My second point is if I go to simplify this guy down here, I can take a look at the top and factor out an h. And I'm left with 2x plus h minus 3 all over h. And there's my second thing. The h's will always cancel. And I'm going to be left with 2x plus h minus 3. The first was that second function, everything cancels. The second is I'll always be able to factor out an h and cancel it with the denominator. Did that happen
I'm confused here in the first step.
up here?
Yeah, in the first step, x plus h squared. So why it is
Okay.
not x squared minus, in place of fx, why it is not x squared minus 3x plus 8?
Okay, so here's something that I used to do. This becomes f of blah equals blah squared minus 3 times blah plus 8. Okay, so wherever there was an x, I pulled and said that's a blah, and that's a blah. Now, whatever I put in here,
Yeah.
I'm going to write there and I'm going to write there.
Okay.
So it's almost like
Oh, so x
forget
plus
this
h.
first. Yeah. So if I put in an x plus h here, I'm going to put it in there and I'm going to put it in there. And yeah, I should have done that from the start. Think of this as f of blah equals blah squared minus 3 blah plus 8.
Got you. Okay. Thank you.
Good, good. I'm glad that helped. I'm glad you brought that up because I should have done this from the start and I did not. Any other questions? All right,
Sir,
yes.
I'm sorry, I just said no, sir.
Oh, okay. I got excited because I like questions. Okay. Composition of functions. I don't know if you know how you go into Kohl's and you see a jacket and that jacket is $80. But Kohl's is like, oh, wait, it's not really $80. We're going to give you 20% off and you're going to get a new price. Okay, if I get 20% off, 20% of 80 is 16. 80 minus 16 is $64. And we're all happy. But then what does Kohl's do? In the mail, you got a coupon for 15, 20, or 30% off. So let's say you got the 30% off and you go and say, all right, I'm going to now use my 30% off and drop this price even a little bit more. And I know that this becomes 64 times 0.7 because that's 70%. It's 70% of this value because I got 30% off. So that's an 8 and that's a 44. And all of a sudden my $80 item is now $44.80. So I took this value, I plugged it into a function and got an answer. Then I took that value, plugged it into a different function and got an answer. We used to do this with Boscov's 25 years ago because they used to have Cracker Jack specials. You'd get a box of Cracker Jack and inside it would have a coupon for a certain percentage off. But this is a function, starts with a value that's domain, and it gives me an answer, which is my range. And then it says, wait, I want that range value to now be a domain. Okay, what I mean by that is this is an X and I get a Y, but I want to turn that into an X so that I get this Y. So I get that answer. All right, and that's what this next thing is, composition of functions. And you're going to see it written as this. f of g of x, but f of g of x is really f of g of x, which means I take my x value, plug it in my g function, then get an answer, and I would plug it in my f function. Well, they're not starting out with values just yet, and I think we should do the values first. So I'm going to skip down to number 15. So this guy, f of g of 9, says f of g of 9. So this is like the original price of that coat. I plug it into a function and I got a new value. Then I took that new value and I plugged it into my next function. So this equals f of g of 9. Again, g of blah equals 2 times blah minus 8. So now I get f of, oh, can't see it, sorry folks. 18 minus 8 is 10. I plug that into this function. I get 3 over 10 minus 4. That's 6. 3 over 6 equals 1/2. Try this one. Try the next one in 15. I'll be there for you. These 5 words. Anybody have an answer? If you don't want to talk, you can type it in the chat. Emma, I just saw in the chat you caught my error earlier. Nice job. 1 point for Gryffindor. Actually, that should be 2 points, yeah. So this becomes g of f of 6. No solutions. Slade has a no solution. All right. Down here, if I want, I can separately find f of 6 and then take that and plug it up there. F of 6, right? Let's see. That's going to give me 3 over 6 minus 4. If I'm doing this wrong, somebody yell at me. Equals 3/2. Slade says, never mind. Okay. So now this becomes g of 3/2. What was f of 6, I calculated and got 3/2. Now I plug it into my g function, and I want g of 3/2, which is 2 times the blah, 3/2, minus 8. The 2's cancel. 3 minus 8 equals -5. Hell yeah. I'm checking the chat. No, nobody had any. I see Nina. You can shake your head yes or no. Did you get -5? Yes, she said yes. Good job. Good job. All right, so let's go back up and tackle these, the generic ones. All right, so here's what I'm going to do. This is f of blah equals blah squared minus 3 times blah plus 1. So when I get ready to do this problem, it equals f of, and let's see, whatever is here goes there. Well, what is g of x? Well, first of all, I need to find g. Oh, that's just 5x plus 4. So in place of g of x, I put 5x plus 4. You notice this isn't with a certain number. It's with an expression of 5x plus 4. Now, I'm going to take that 5x plus 4, plug it into my f function. So it's all of these blahs. So it becomes blah squared, 5x plus 4 squared, minus 3 times 5x plus 4 plus 1. It really is a lot cleaner to look at that way, I think. This equals g of f of x, which means g of x squared minus 3x plus 1, which means I plug all of this into there. 5 times x squared minus 3x plus 1 plus 4. I'll do this one. 5x squared minus 15x plus 5 plus 4 plus 9. Yay. Hopefully you're working on 13. Going to go slow. Am I good so far? 25x squared. I have the 40x in that, so it looks like plus 25x. 16 minus 12 is 4. Plus 1 is 5. Can you dig it? All right. 14 is another one just like that. I'm going to leave that empty. If you lack confidence on this, do these two. Email if you have questions or bring it up at the beginning of Tuesday's class. We can come back and take a look at them. Oh boy. Let's do this one. F of g of x. That's going to be f of g of x. And I can plug that right in, f of 3x minus 2. Straight up substitution. F of blah equals 3 over blah plus 2. 3 over blah plus 2. Equals 3 over 3x. Huh. That equals 1 over x. Now, what's the domain? Doesn't matter. I was already writing it down because as soon as I see something, like, whoa, 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 x cannot equal 0. Okay, 17 and 18 are kind of like, yeah, okay, fine. So what they're saying is, if I have f of g of x, I want to end up with 3x minus 7. So they're saying, give me a g of x and give me an f of x. Well, we could simply do something like this. G of x equals 3x minus 7. F of x equals the square root of x. So that when I do, and it's not something you normally see because there's so many possible solutions. But when I do f of g of x, this becomes f of the 3x minus 7. And then I take that and plug it in and get the square root. So it's coming up with 2 functions to give this to me. So my first function was what's inside. My second function was the square root. Not something you normally do after this point. Again, the biggest thing out of this section so far was the difference quotient. All right, so we have number 19. I'm going to pause the video. All right, let's see what we got. What do we have? Again, f of x is my y values. I say f of 3, I go over 1, 2, 3. I go to my f function, 1, 2, 3, 4. So I now have 4 minus g of 3, 1, 2, 3, 1, 2, 3. I got 1. I went over to 3. And I checked out my f function, which was 4, my g function, which was 3. Huh, I didn't really have to do much work because I could have just looked at that distance, and that distance right here, yeah, that was 1. Okay. Somebody give me an answer for B. Anybody?
-2.
Excellent, -2. G of 2 is down here. That's -4. F of -2 is up here at 2. I agree, -2. I concur. Somebody have an answer for C? Well, let's start with what is f of 1? F of 1 is 2. Need to now plug that into my g function. Wow, you folks are really quiet today. I have 4. More composition. F of g of -3. My g function is this red one, -3, 1, 2, 3. That's -4. What is f of -4? Here's my f function, this black one, f of -4, looks like it's going to be -2. Hopefully in your groups, which I didn't have time to get around to all of them, you were active doing this. F of -3. Here's my f function. -3 is 0. F of 0, +2. What you think about that? I need to see 3 thumbs up. And I only see, so there's 1, 2.
This is my kryptonite, Professor. I'm just sitting here trying to
Okay,
remember as much as possible.
all right. So you're getting all the numbers and notes down, right?
Yes, sir.
Okay. You come up with a question, let me know. Because you know I like questions. Oh boy. Last problem of the day. Oh boy, oh boy. Look at all those words. I'm waiting for somebody to say, "Hey, I didn't know this was an English class." A party balloon is being filled with helium. In the world of the problem, okay. As the balloon is filling, the radius of the balloon is changing at a rate of 3 inches per second. All right, radius is changing at a rate of 3 inches per second. Sounds like it's constantly growing. Write a function that represents the radius r of t, radius in terms of time, after t seconds. All right, so going back to like 3rd grade, you did this simple thing. You did time and you did radius, and you looked at a chart, and that's all you did. You didn't do anything else after that. As the balloon is filling, the radius of the balloon is changing at a rate of 3 inches per second. So when I'm at 0, I'm going to assume it's 0. When I'm at 1, what would the radius be? After
3.
1, 3. When I'm at 2, what would the radius be? Well, another,
6.
yeah. So now I have some data points. And back in elementary school, that was it. That's all you needed to do. You weren't talking much about that. As you went through, you started to do, okay, so now I have an equation I need to come up with. And we have lots of ways to do this. 0, 1, 3, 2, 6. And I'm going, okay, I think I have enough information there. Y equals mx plus b. I know b is 0 because that's my y-intercept. So b equals 0. Good, I don't need to worry much about that. And now I need my slope. And we didn't use it very much, but some of you know slope is rise over run. So I'm going to rise 1, 2, 3. I'm going to run 1. I found a slope of 3. Okay, so my equation, y equals 3x, but I'm going to put it in terms of time and radius. So up here, it's just going to be 3t. Okay, not too bad. Bunch of words there. I didn't want to do this word problem, but I just started to plug away. Write a function that expresses the volume of the balloon in terms of radius. Oh boy. Does anybody know what the volume of a sphere is?
It's 4/3 pi r cubed.
Excellent. 4/3 pi r cubed. Excellent. It's 3-dimensional, so I better have a cubed of some sort in there. Okay, still not panicking. It was a big problem. Lots of questions and a whole bunch. Okay, we survived so far. V of R of t. V of R of T. Well, we just worked on that a little bit, and I think we can do this. V of R of T. So when I plug in, that's 3T. So now I have V of 3T. Because now I'm going to get we'll talk, it says interpreted in a minute. So V of R of T. So now I'm going to plug 3T in for my blah. And it looks like I'm going to get 4/3 pi 3T cubed. 3 times 3 is 9 times 3 is 27. But I know one of those 3's is going to cancel with this 3. So now I get 3 times 3, which is 9, 36 pi T cubed. And that equals V of R of T. I need to make sure that's an open circle so you don't think it's multiplication. So what's this saying? Here, I was able to do the radius in terms of time. Now I'm able to do the volume in terms of time. After 1 second, I know what the volume of the balloon is going to be. After 2 seconds, after about 5 seconds, chances are my balloon popped, as we all know. Here it is, after 2 seconds. Well, I want to plug that in V of R of T. Well, I can just go right here. 36 pi T is 2 cubed. 2 times 2 is 4 times 2 is 8. 8 times 36 is a whole bunch, 288. Pi, which means that is the volume of the balloon after 2 seconds. Crazy.